Hi guys, so for this video I picked out a very difficult question on parametric equations. We're going to have a go at differentiating them. This here says dy dx, by the way, sorry if you can't see it. We're going to have a look at forming Cartesian equations and also equations of the normals and how that relates to dy dx. I'll remind you guys how later on. I've also written out these two identities. If you wanted to have a go yourself, feel free to. So it says find dy dx in terms of t. So how do we do that? Well, we can differentiate y with respect to t because we have an equation for y with respect to t. And we can differentiate x with respect to t because of the same reason. Can we somehow combine these to get to dy dx? Yeah, actually we can. Because we know that dy by dt multiplied by dt dx gives us dy dx because the dt is horizontally, diagonally, they cancel each other out, leaving you with just dy dx. One thing to bear in mind is dt by dx is the reciprocal of this. So once you find what dx by dt is, you can do the reciprocal to find dt by dx. So let's take a step by step now. The differential of root 3 cos t, 2t, well, this itself is a composite function, a function inside of a function, 2t inside of cos t. There's a rule in general, which I write out. If you'd like me to go through using the chain rule, just let me know. But if we have a function cos ax, then dy dx is going to be minus a sine ax. This will always hold true whenever there's a constant where a is. In that case, cos 2t differentiates to minus 2 sine 2t. So let's write that out. So cos of 2t, if y is equal to cos of 2t, then dy by dt would be minus 2 sine of 2t. Before you comment, oh, you made a mistake, now we're going to take into account of the root 3. We're going to multiply it onto the y. And in that case, we just treat it as a constant. So you multiply it onto dy by dt. So it becomes minus 2 root 3 sine 2t. So let's write that out. Minus 2 root 3 sine 2t. That's your value of dy by dt. Let's now find dx by dt. So cos just differentiates to minus sine. In that case, we just, again, treat this as a constant and you multiply onto minus sine t. In that case, dx by dt is equal to minus 2 sine t. Let's now use those, and we can, because dy by dt, we can replace that with minus 2 root 3 sine 2t. And we multiply onto that dt by dx, which I mentioned is the reciprocal of all of this. So 1 over minus 2 sine t. When you're cancelling out now, the minus 2 here cancels out with the minus 2 in the denominator. Sine 2t, I've written out the double angle or compound angle formula, here, because we can expand out sine 2t. And let's do that now. 2t is essentially t plus t, right? So what we can say is that this is just sine t cos t plus, well, sine t cos t. Because we're adding it to itself, we can just say it's equal to 2 sine t cos t. So we can replace the whole numerator with root 3 multiplied by what we just found, 2 sine t cos t. So let's do that. So we have, so I'm going a little bit all over the place. Root 3 sine t cos t all over sine of t. Remember, we've already cancelled out the minus 2. But here we can now cancel out the sine t's and we're left with root 3 cos t. Is that a minus? No, it isn't. I'm sorry. It looks like a minus. So yeah, that's it. We're left with root 3 cos t. And that's your expression for dy dx. Let's now erase all of this because we're going to run out of space if we don't. If you guys do need to look over it, you can just rewind the video. But I'm just going to write out the value of dy dx because I'm sure it'll be useful later. And just leave the whiteboard a little bit clearer. So it was root 3 cos t. Yeah, okay. Root 3 cos t. Was it? No, sorry, it was 2 root 3 cos t. Sorry, I did the working out beforehand. And yeah, it was 2 root 3 cos t. After you cancel everything out. Okay, let's now use that in this next part of the question, part B. It says the point P lies where t is equal to 2 pi over 3. Now, I think it's going to help straight off the bat if you find the x and y coordinates of point P. You can do that because we know an equation that links x and y to t. It's just this equation here. Remembering to put your calculator in radians mode, you can just put 2 cos of that t value there, 2 pi thirds. And do a similar thing for y. So y equals root 3 multiplied by cos of 2t, so that's 2 times this angle. 2 times 2 pi is 4 pi over 3. The x value that comes out is the x value of -1, and the y value that comes out is -√3/2. Perfect. So -1 minus √3. Oops. Sorry. Quite struggling quite a lot for space today. -1 minus √3/2. Okay, let's move on. It says the line L is a normal to C at this point, at this coordinate. What does a normal mean? So let's very briefly recap it in terms of curves. A tangent is a line that matches the gradient of the curve at that point. So essentially, if you wanted to find the gradient of a tangent, you just do dy dx. So I'm just going to very quickly write that out because it is going to help us in this question. So if you find dy dx and you substitute the x, y, or t coordinate at that point into it, you get the gradient of the tangent. The normal, however, is a line that's perpendicular to the tangent. So its gradient is -1 over the gradient of the tangent. So let's start by finding, well, because it's a straight line, we know it's going to be in the form y equals mx plus c, just as it's written out here. We're going to start by finding the gradient of the normal. So like I mentioned, the gradient of the normal is -1 over the gradient of the tangent. So let's find -1 over the gradient of the tangent. I'll just write m of tangent because I don't want to waste your guys' time writing out quite a lot of information. To do that, we have the dy dx formula, which gives a gradient 2√3 cos t, and this is actually where it's useful. We know that it's 2√3 times cos of the t value at that point p. It tells you it's 2 pi thirds, so you can just put 2 pi thirds into your t. Once again, remember to put your calculator into radians mode. This all equals 1 over √3. Does it? No, it doesn't, sorry. Minus √3. What does it equal 1 over minus √3? Yeah. What does equal 1 over √3 though? By the way, this is just 2√3 cos t, that's equal to minus √3. And then when we do -1 over all of this, that's what I was talking about actually. So -1 over minus √3, that's what's equal to 1 over √3. And that's the gradient of the normal. Now that we have the gradient of the normal, we now have to find the c value. So let's put into the expression first, y equals 1 over √3x plus c. Since we know the x and y coordinates at that point t equals 2 pi over 3, we can put x equals -1 into this and y equals -√3 over 2 into this. So let's do that. -√3 over 2 equals 1 over √3 times x, which is 1 over √3 times -1. So that's -1 over √3, all plus c. You add 1 over √3 now to both sides to find the value of c. So c is going to be -√3 over 2 plus 1 over √3. I recommend combining this into a single fraction by using the smile and cross method. So -√3 times √3 is -3. 2 times 1 is 2, all over the multiplication of the two denominators, which is 2 √3. -3 plus 1 is -1, so that's -1 over 2 √3. Now we can combine this, or put the c value into the expression that we formed originally, and we have y equals 1 over √3x, and then -1 over 2 √3. Although this is perfectly valuable for the equation of the normal, it specifically wants you to show that it can be written in this format here. I think the best way to do that is, well, realizing that we're currently at just y, whereas this is a 2 √3y, a 2 √3 before the coefficient of y. So perhaps if you multiply each individual term by 2 √3, it will put it into this format. So let's do that. The term on the left hand side becomes 2 √3y. 2 √3 over √3, well, that will cancel out because the √3's cancel out, and we're left with just 2 on the denominator, so it becomes 2x. Minus, and then 2 √3 over 2 √3 is just 1, and then you want to move all the terms to the right hand side just so it looks pretty much like that. If we just subtract -2 √3y from both sides, we can just squeeze that in here. So it becomes -2 √3y minus 1 all equals 0. And that's it. That's everything for that part of the question. Once again, I'm going to erase some of this information, but a little bit quicker this time. Oh, no. You don't want it to erase the whole question. Is that as far as I can go? No, I can do a little bit. Oh, yeah, that's fine. Okay, so we don't need to write out that equation. It's already written out for us. I'm sure it'll be useful in the next step. Yeah, actually it is. It says the line L, which is represented by this whole expression here, intersects the curve C, which has these equations, again at the point Q. Find the exact coordinates of point Q. So where the parametric equations intersect with this curve, you want to somehow combine the two expressions together. I'd recommend replacing x with 2 cos t. So it becomes 2x becomes 4 cos t. So let's write out here. 4 cos t minus 2 root 3 multiplied by y. Well, y, we're going to replace it with root 3 cos 2t. Root 3 cos 2t. Hopefully you guys have realized that you can just do 2 root 3 times root 3 to get to 2 times 3, which is 6. So let's write this whole term out as 6 cos 2t. I'm sure it will speed things up later on. And then minus 1 is all equal to 0. Now, how do we solve something like this? Well, it almost looks like a quadratic, and if this was a squared term, it'd be easy to use quadratics, in my opinion. Well, not easy, but easier. So how can we make it so that it's an equation only in terms of cos t? Not cos 2t. Well, that's where we can use the second expression that I've written out. Once again, we can replace a with t and b with t. In that case, cos of a t plus t would represent cos of 2t. And that's equal to cos t times cos t. So that's cos squared t minus sin t sin squared t. But then you're probably thinking, okay, but that gets sine into the whole expression. How's that going to help? Can we make this so that it's only in terms of cos t, that is? Yeah, we can. Because what we can do is we can replace sin squared t with 1 minus cos squared t. That helps a lot now, because now we can say that's cos squared t minus 1 minus cos squared t. So that's plus cos squared t. The cos squared t terms, you can collect them as like terms and they become 2 cos squared t. Now you can replace cos 2t with all of this. So we have 4 cos t minus 6 lots of 2 cos squared t. Sorry, I think I've got something on my throat. Minus 1 all equals 0. You can expand out. So let's do that. 4 cos t minus 12 cos squared t minus 6 times minus 1 is plus 6. Minus 1 is all equal to 0. I think it's best, honestly. Well, first of all, 6 take away 5 is 1 is 5. And I think it's best if we take everything to the right hand side, just so we get a positive squared term. Whenever you deal with quadratics, you always want it to be a positive, if it's possible. It's a lot easier to solve. So minus 4 cos t minus 5 all equals 0 when you move everything to the right hand side of the expression. So in that case, it's this side that equals 0, just in case you guys are confused by that. And then we factorize here. What you should get when you factorize is t equals 2 pi over 3, because we know for sure that's one of the points where the normal meets the curve. This normal meets this curve. But the other value of t is what we're looking for. Once we have that other value of t, we can put it into the expressions of x and y, and that will give you the alternative coordinates of x and y, which are point q. So let's do that. 12 times minus 5 is minus 60. What two numbers multiply to give minus 60 but add to give minus 4? It's actually minus 15 and... Sorry, no it isn't. It's minus 10 and plus 6. So we can write out 12 cos t. If you'd like me to break this down further, just let me know. I'll make a separate video. This is a topic of hidden quadratics. I'm just skimming through a little bit because this is an A-star question. So if you've clicked on this, it's bold to assume, but hopefully you guys understand how to do this. So from here, I'm simplifying both brackets. 6 cos t minus 5, 2 cos t plus 6, all equals, oops, sorry. We divided this by 6, so we have to divide this term by 6 as well. Plus 1, all equals 0. Now this has two solutions. Either when the first bracket is equal to 0, which is when cos t is equal to 5 over 6, or when the second bracket is equal to 0, which is when cos t is equal to minus 1 over 2. Now, what you'll see is that you might be thinking, which of these do we use? Well, if you do a quick inverse cos to see which one gives you a t value of 2 pi thirds, you'll see that this only has a solution when t is equal to 2 pi over 3 on the calculator. However, this is the alternative solution. Now, rather than finding the t value here, it wants you to find coordinates, but the exact coordinates of q, using the fact that, okay, I'm going to actually screenshot these, just because it'll be quicker, and I can bring it up here. Yeah, now that we have the t value, we can honestly just, I don't know if you've noticed, but we can just put it into the x and y equations, because we can say x is equal to 2 times this value here, 2 times 5 over 6. So 2 times 5 is 10, 10 over 6 is, well, it can be written as 5 over 3 if you simplify it. and putting it into the y expression, y is equal to root 3 times cos of 2t, which is 2 times 5 over 6. And we just mentioned 2 times 5 over 6 is 5 over 3. Oh, sorry, what am I doing? This is a little bit more complex. You can't just replace it like that. To replace it, we have to actually use the fact that what we introduced before, cos squared being cos 2t being 2 cos squared minus 1. So replacing, sorry, you can probably hear my voice. I'm starting to get a little bit tired now. It's quite a long video. But you can replace cos 2t with cos squared t minus 1. And you can say this is the root 3 multiplied by cos t, which is 5 over 6, all squared minus 1. We couldn't replace it before because there was an angle of 2t, and you can't just manipulate that by doubling it. When you square this becomes 25 over 36, take away 1, all multiplied by root 3. 1, we can just replace it, so it's 36 over 36. Why we do that? Well, so that it matches the denominator, and we can easily subtract the numerators of the fractions. 25 take away 36 is minus 11 over 36. And then that's minus 11 root 3 over 36, providing I haven't made any mistakes. Yeah, that's it. So your final x and y coordinates are 5 over 3 and minus 11 root 3 over 36. Very difficult question, and hopefully it made sense to you guys. Thanks for watching, and if it helped, please be sure to leave a like and check out the rest of my A-star videos on my A-star playlist. Thanks for watching. I hope this video helped. If you have any tutoring inquiries, be sure to visit my website www.excellineducation.co.uk. It's on the first link in the description too.